This is section 2.3, problem number 32, and it's giving us this function and asking us to find the values of x where the derivative of this function is equal to 5. So I wrote the problem down. I'll switch over to my iPad. If I can find it. I can't find it. So I will pause the recording and then you will see my iPad. All right, so in order to find out when the function's derivative is equal to 5, I actually have to find out what the derivative is. So that's the first thing I'm going to do is find the derivative. And I'm noticing that this function is a quotient. So I'm going to use the quotient rule to find the derivative. And for the quotient rule, you're going to use that rule when you have like a fraction, like a function over another function. And quotient rule says that the derivative is the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. So using this rule, I can find out what my derivative is. So I'm just going to label my numbers, or sorry, my expressions, my numerator and my denominator. So I'm going to call my numerator my f. I'll refer to that as my f. This is, here I'm going to actually write this underneath my quotient rule. So this is within the quotient rule, my numerator is x, and then my denominator is x plus 6, so that's going to be my g. And the derivative of x is just 1 because it's like there's an invisible 1 here in front of that x. And the derivative of a constant times x is just the constant. I forgot to put derivative here. So f prime, I forgot my prime. So f prime equals 1. And then the derivative of g, again, imagine this invisible 1 in front of the x there. So g prime will be 1 plus 0 because the derivative of a constant is just 0. So this is just 1. Wow. So both f prime and g prime are 1. So from here, we can now find our derivative using the quotient rule. So I'll have f prime of x equals, I'm going to have this fraction bar. And I start off with my f prime, which is 1. And then this is times my g, which is x plus 6. And then we have minus, there's a minus in the rule. And then we have f, which is 1x. So, and then times my g prime, which was just a 1. So that's what I have. And then this is over my derivative, x, sorry, not my derivative, my denominator, x plus 6 squared. So my denominator squared. And since I will be I will be like setting this equal to 5 and solving for x, I'm going to simplify this as much as I can. I know I haven't been simplifying in this section, but now I'm going to simplify because I have a reason to. I have 1 times x plus 6 minus 1 times x. So I just have x plus 6 minus x after distributing this 1 and then just multiplying 1 times x times 1. That's x. The x's end up canceling. So I end up with just 6 over x plus 6 quantity squared. And I want to find out, I'm being asked to find out when this expression is equal to 5. So now I'm going to take this and set it equal to 5. So I have 6 over, actually, I'm going to give myself some more room. So I have 6 over x plus 6 quantity squared, and I want to find out when this is 5. And the reason I wanted to give myself some room is because I see that I have a fraction here. And in general, if you want to if you have an equation that involves fractions, you can get rid of that fraction right away. by multiplying both sides of the equation by the denominator. So that's what I'm gonna do right off the bat. And then these cancel, that's what I wanted. And so now I end up with 6 equals 5 times x plus 6 quantity squared. And next I'm going to get rid of the 5 by dividing both sides by 5. So I'll get rid of my 5 and I'm left with 6 over 5 equals x plus 6 quantity squared. And I'm trying to get x by itself, and right now it's like trapped in that x plus 6 quantity squared. So I'm going to get rid of the square by taking the square root of both sides. Just make sure that you put plus or minus on the other side, because you can square a positive and get the same result as when you square like a negative. So put the plus or minus. And then from here, I end up with plus or minus root 6 over 5 equals just x plus 6. Because the square and the square root, they cancel each other out. That's what we wanted. And then last of all, I just need to get x by itself. So I'll subtract 6 from both sides. And even though this looks messy, our answer is going to be -6 plus or minus root 6 over 5. And I think they want us to write it as like 2 separate answers. So we'll have -6 plus root 6 over 5, and then -6 minus root 6 over 5. And I'm going to go ahead and enter this. Let's see if it works. See if I made any mistakes. So the greater solution, that's going to be the one where I add the -6 plus root 6 over 5. That's going to give me the bigger number, right? And then the lesser solution, that's when I'm subtracting. So -6 minus square root of 6 over 5. And there we go. I hope that helps. Bye.